Well, thank you very much. I'm greatly honored to be here and to deliver this inaugural Copernican lecture. I've been in Poland for about 5 days, and these were really exciting and fantastic days. I learned to appreciate both the Polish people and the Polish countryside and the cities. I was particularly impressed by Toruń. I find it exceptionally beautiful and enchanting. Now, my lecture today will focus on a research agenda that I advanced in the past decades, a research agenda that was designed to shed light on two of the most fundamental mysteries of the growth process. The first one is the mystery of growth, namely why economic growth emerged in the past 2 centuries after literally hundreds of thousands of years of stagnation. And the second one is the mystery of the gaps. What is the origin of this vast inequality across countries and regions of the world? Now, the vast inequality in income per capita across countries, regions, and ethnic groups is striking and puzzling. The wealthiest regions of the world are nearly 30 times richer than the poorest one, and the wealthiest countries in the world are nearly 100 times richer than the poorest one. And naturally, the question is, what is the source of this great inequality in the wealth of nations? Now, if we consider inequality across individuals within a nation, this is simple to comprehend. We differ in our productive traits, cognitive traits, physical traits, and we live in a market economy that rewards differentially productive traits. And as a result of it, inequality is an inevitable byproduct of the fact that we are heterogeneous on the one hand, and the fact that we live in a market economy that complements and rewards differential trait differentially. But what is the origin of inequality across nations? Nations, after all, are a collection of individuals. And unless nations differ systematically in the collection of individuals that live in them, one should not expect inequality across nations to persist over a prolonged period of time. If we take a step back in the course of human history and we focus on the evolution of inequality in the past 200 years, it is quite apparent that inequality was insignificant 200 years ago. At the beginning of the 19th century, it appears that inequality, as measured by the ratio of income per capita in the wealthiest regions of the world in comparison to the poorest regions of the world, is only at the magnitude of about 3-to-1. And then, in the course of industrialization, in the course of the transition from stagnation to growth and the differential timing of it, we see the emergence of a huge inequality in the world economy. In fact, if we take a step even further backward and we look at the evolution of inequality in the past 2,000 years, since the year 1, it appears that inequality was negligible over most of human existence, and then, at a certain point, at the beginning of the 19th century, it appears that the world is reaching a singular point, a point of departure in the evolution of different regions of the world. Some regions of the world, Western Europe and their offshoots in the New World, are taking off very, very rapidly. Other regions of the world, such as Sub-Saharan Africa, are lagging behind. And consequently, a huge inequality is emerging in the world economy as we see it today. Now, if we focus on neoclassical growth theory suggests to us that due to the fact that there are diminishing effects of physical and human capital formation, and due to the fact that there are diminishing effects of technological progress on economic development, inequality should be expected to subside over time. And in fact, convergence would be expected to appear in the world economy. But in fact, as I just argued, in the past 2 centuries, inequality is widening rather than shrinking. And in fact, this phenomena is not very different in the past few decades. So if you focus, for instance, on the evolution of inequality from the 1960s to the 1980s to the 2000s, it appears that, if anything, inequality is widening a little bit in this process. So again, in contrast to the influential prediction of the neoclassical growth model, it appears that, in fact, economies are diverging over time rather than converging over time. Now, if we focus on a different angle of this inequality, and if we measure the position of economies relative to the United States in 1980 along the x-axis, and the position of these economies relative to the US in the year 2010 relative to the US, it appears that most countries are clustered around the 45-degree line. Namely, it appears that countries on average do not change their position relative to the United States over these 3 decades. Namely, the prediction of the neoclassical growth theory about convergence does not appear to be present in the data. Yes, there are some examples of China, for instance, that is naturally above the 45-degree line, where convergence is taking place. Korea is above the 45-degree line, convergence is taking place, but there are a significant number of countries below the 45-degree line, namely countries that are diverging even further from the United States over this time period. And overall, the picture that emerges is a picture of persistent inequality in the past few decades and enormous divergence over the past 2 centuries. Now, naturally, if you review this evidence, few mysteries are emerging in the context of the journey of humankind. As I said earlier, the mystery of economic growth. Why is it the case that economic growth emerged only in the past 2 centuries after literally 300,000 years of stagnation? If you focus on economic development over this 300,000-year period, the standard of living is fluctuating without any trend for a prolonged period of time. And then suddenly, in the course of industrialization, we see this enormous spike in the growth rate, and income per capita in the world economy is increasing by a factor of 14 within 200-year period. And as I said, the question that emerges that is vital for the understanding of the growth process is, what is the origin of this vast improvement in the standard of living in the past 2 centuries? In addition, what we see over this time period is the emergence of huge gaps in inequality across nations. And this naturally raises the important question, what is the origin of this vast inequality across nations? As I stated earlier, we wouldn't expect systematic and persistent differences across nations unless nations will differ systematically in the composition of their human population. In addition, the evidence raises important questions about what accounts for the divergence in income per capita in the past 2 centuries. And what are the factors that inhibited the convergence of poorer economies into richer ones in the past few decades? And as we will see momentarily, perhaps most importantly, we would like to understand what is the role of deep-rooted factors, historical factors, prehistorical factors, biogeographical conditions that were formed literally hundreds of years ago, thousands of years ago, and as we will see, even tens of thousands of years ago, on the divergence in income per capita as we see it today. Now, a resolution of these mysteries, as you will see momentarily, requires then the identification of the forces that permitted the transition from stagnation to growth. namely those endogenous, spontaneous forces that permitted some economies to move from stagnation to growth and cause others to remain trapped in the Malthusian epoch for a prolonged period of time. In addition, we will need to understand the origin of this differential timing of the transition from stagnation to growth. Why is it the case that Western Europe and Western offshoots are taking off as early as the beginning of the 19th century, and other regions of the world, sub-Saharan Africa, is lagging behind, as in fact is not taking off yet? In addition, we would like to understand, as I said, what is the role of the historical and prehistorical factors in the process of development, and, as you will see momentarily, what is the contribution of evolutionary processes in the transition from stagnation to growth? Once we will have the resolution of these two important puzzles, we will be in a better position to prescribe policy that is country-specific, as opposed to universal, efficient policies that will allow less developed economies to expedite their transition from stagnation to growth, and in addition will allow for the narrowing of global inequality as we see it today. Now, if you will review the evidence, it will become very apparent that in fact much of what we see in the world economy today has very important deep roots. And consequently, in order to understand the process of development, and in order to understand the differential timing of the takeoff from stagnation to growth and the vast inequality across countries, we will need to understand the process of development in its entirety. So if you think about the process of development, one can segment the process of development into three fundamental phases. First, the Malthusian epoch. Second, what I will define as the post-Malthusian regime. Third, the modern growth regime. The Malthusian epoch emerges at the time that anatomically modern humans are emerging in Africa 300,000 years ago, and it lasts till the eve of industrialization, till the middle of the 18th century in the context of the most developed countries in the world. Naturally, some countries in the world are still trapped in the Malthusian trap. So the Malthusian epoch lasts over 99.9% of human existence. Now, the Malthusian epoch is characterized by a certain dualism. On the one hand, it reflects stagnation. Income per capita is fluctuating tremendously around the subsistence level of consumption. But at the same time, there is great dynamism over this time period. Technology is advancing very slowly, but over a 300,000-year period, this slow improvement is ultimately generating technological acceleration as we see it at the time of industrialization. In addition, what we see in the world is that during the Malthusian epoch, there is great dynamism in the sense that natural selection is operating and traits that are being selected are complementary to the growth process. So individuals that have traits that are generating higher prosperity have higher reproductive success, and as a result of it, the selection process, whether it's biological or cultural, is basically increasing the prevalence of human traits that are complementary to the growth environment and are expediting the transition from stagnation to growth. At a certain point, due to this acceleration in technological progress in the course of human history, the pace of technological progress becomes so rapid that ultimately biological reproduction cannot catch up with the rate of technological progress. And at this time period, we see the emergence of economic growth. This occurs in the context of the most developed countries in the world only about 250 years ago. Now, this spike in economic growth is associated with an important spike in population growth, because during the Malthusian epoch, There is a positive relationship between income and population, and consequently, when income is rising very rapidly, we see an enormous increase in the size of the population in each region and in the world as a whole. And then, towards the end of the 19th century, around the 1870s, in the context of the most developed countries in the world, we see the onset of the demographic transition. Technological progress accelerates. The technological landscape in which people are operating is changing very rapidly, and consequently, individuals find it beneficial to start to invest in human capital. As they invest in human capital, given limited resources, they have to economize on the size of their families. We see a dramatic decline in fertility, and consequently, the growth process is freed from the counterbalancing effect of population. So as I said, if you think about the Malthusian epoch is characterized by important dualism, stagnation along with dynamism. We have stagnation in living standards that are reflecting by the fact that income per capita is fluctuating around the subsistence level of consumption. And we have stagnation in living standards reflected by the fact that life expectancy is fluctuating in the neighborhood of 25 to 40 years over the past 300,000 years. But as I said, the Malthusian epoch is characterized by great dynamism. Technology is advancing, and as a result of it, larger and larger population is being supported. If you think about the population of planet Earth in the year 1, at the time of Jesus, if you wish, then the size of the population is about 170 million people. If you think about the size of the population of planet Earth in the eve of industrialization in 1750, it is about 750 million people. A four-fold increase in the world population in a time period that is characterized by a period of stagnation. So this is a time period, as I said, in which technology is converted primarily into larger and larger population rather than an increase in the material well-being of this population. Now, in addition, during this period, as I said, there is an evolutionary process. People are adapting in terms of their traits to the technological environment, and this adaptation becomes instrumental in the context of the transition from stagnation to growth. So when we think about the Malthusian epoch, we should think about two central characteristics. The first one is a positive effect of income on population. When people have more resources, child mortality declines, fertility increases, and life expectancy increases. And consequently, there is positive effect of income on population. Unlike today's world, this is a time period in which richer people have higher reproductive success. But at the same time, this is a time period in which land is a constraining factor of production. So as the population of the world increases, resources per person are shrinking, and technology, or the advancement in technology, is simply offsetting this process of declining resources per person due to the fact that population is expanding. And as a result of it, technological progress over this period permits societies to produce more than before. Temporarily, we see an increase in income per capita, but this is not long-lasting. An increase in income per capita permits larger population to be supported, population adjusts, and as long as income is above subsistence, population continue to grow, and ultimately income per capita is brought back to the previous equilibrium position. This is very important because what it implies is that during the Malthusian epoch, technologically advanced economies are not necessarily richer, they are simply more densely populated. So again, in today's world, technological prosperity is converted into material prosperity. But In the Malthusian epoch, that, as I said, lasted over 99.9% of human existence, technological advancement was converted into more people, but not richer people. And the evidence are unambiguous about it. So if you focus, for instance, on the relationship between productivity in the year 1500, okay, as measured by population density, and land productivity in this time period, you can see that countries of the world that have better soil quality, larger population density. Now, this by itself is not very surprising. Naturally, I wouldn't expect that population density in the Sahara Desert will be larger than population density in the fertile regions of Poland. But the puzzling and the striking element is that there is no relationship between land productivity and income per capita. If you have better soil quality, you will support more people, but not richer people. And the same is true for technological advancement. If you have a more advanced technology, then this will be converted into higher population density. But if you have a more advanced technology, you will not enjoy higher level of income per capita up till very recently. And as a result of it, as I said, over 99% of human existence, technological progress is converted into more people, but not richer people, and consequently there are no variations in income per capita across the globe, and at the same time there are great variations in population density across the globe. Now, as I said earlier, and this is very important, during the Malthusian epoch, we see the evolution of human traits. And why is it so? Naturally, the Malthusian pressure, as I just argued, determines the size of the population. But it doesn't determine only the size of the population, it determines the composition of the population. And why is it so? Well, if there are certain traits, hereditary traits, that generate higher income, in the Malthusian epoch, they will generate higher reproductive success. Richer people have higher reproductive success. And consequently, if the richness is originated in better or in more appropriate cognitive or physical traits, and if these traits are transmitted intergenerationally, this would imply, as I said, that these traits will become more and more prevalent in the population. So during the Malthusian epoch, there is a gradual process, evolutionary process. It can be biological, it can be cultural, and during this process we see a gradual increase in the prevalence of complementary traits to the growth process that reinforces the growth process and ultimately contributes significantly to the transition from stagnation to growth. In addition, during this time period, the size and the composition of the population are affecting technological progress per se. And why is it so? Naturally, larger populations will have larger upper tail of the ability distribution that can matter for technological advancement. So the supply of innovations will be larger. Larger population will support more demand for innovations. Larger population will increase the diffusion of innovations. Larger population will allow us to be engaged in the division of labor and via learning by doing to advance technologies. Larger population will allow us to trade and via reverse engineering to enjoy from technological advancement. And in addition, due to the selection of traits that are largely reflecting predisposition towards human capital, the gradual increase in the predispositions of individuals towards human capital will contribute by itself to technological progress. So what does it imply? It implies that over 99.9% of human existence, there is an interaction between population and technology that ultimately causes technological progress to change very, very rapidly. And this will mark the onset of economic growth. So we reach a stage in which this positive feedback loop between population and technology is such that the rate of technological progress accelerates so rapidly that as a result of it, income, okay, despite the fact that it has still positive effect on population, it will be the case that technological progress will outpace the biological reproduction, and we see the emergence of economic growth. Now, importantly, the emergence of this post-Malthusian regime occurs in a different time period across the globe. So as I said before, if you look at the takeoff in Western Europe or in Western offshoots, the US, Canada, New Zealand, and Australia, it occurs at the beginning of the 19th century. But if you look at other regions of the world, in particular Africa, Africa is lagging behind. And consequently, this differential timing of the transition from stagnation to growth is generating an enormous divergence in income per capita across the globe. So this takeoff is not only increasing the material well-being of the population, it is basically contributing tremendously to the inequality that emerges in the world economy. Now, technology continued to accelerate over this time period, and ultimately, the pace of acceleration is so large that, in fact, there is a demand for human capital so as to allow people to cope with this rapidly changing technological environment. So industrial demand for human capital is emerging. People start to form human capital, but in order to form human capital, given the budget constraint that they face, they must be engaged in reduction in fertility rates. Fertility starts to decline, and as a result of it, this decline in population growth and in fertility rates frees the growth process from the counterbalancing effect of population. As I said before, during the Malthusian epoch, when technology advanced, population advanced too and brought income per capita back to the previous equilibrium position. But in the modern growth regime, when technology advanced, since fertility rate was on the decline, in fact, the counterbalancing effect of population disappeared, and the world started to move into the modern growth regime. So now, technological progress, human capital formation, and the decline in population growth all operated towards a transition into sustained economic growth. And when we refer to sustained economic growth, we refer to the time period, say in the context of the most developed societies in the world, the past 150 years, in which the growth rate is relatively stable, and it is about 2% per year on average in the past 150 years in Western Europe and Western offshoots. But the transition to the modern economic growth is not universal. Some societies are lagging behind, as we argued before. You can see that Africa is lagging behind. And in fact, Africa was in a state of stagnation over much of the period. But on the other hand, places like Asia are entering into the modern growth regime, and other regions of the world are still struggling. Now, importantly, the demographic transition that is so important for the transition to sustained economic growth is not occurring in the same time period across the globe. Some regions of the world are experiencing the demographic transition as early as 150 years ago, other regions of the world only very recently. And as a result of it, a huge gap is being created in the wealth of nations. So as you can see here, if you look at the relationship between the time elapsed since the demographic transition and income per capita today, there is a pronounced positive association between the two. Namely, those societies that experience an earlier demographic transition are the societies that are more prosperous today on average. And consequently, if you look at the world starting from 1870, as I said, in 1870, inequality in the world is moderate. But then, the differential timing of the demographic transition is permitting this great divergence in income per capita as we see it today. Now, The review of this evidence, as I said, accentuates the importance of understanding these two mysteries that I outlined. The mystery of growth, why economic growth emerged in the past 2 centuries after hundreds of thousands of years of stagnation, and the mystery of the gaps, namely what is the role or what is the origin of the vast inequality across countries that we see in today's world. But most importantly, it basically takes us back in human history, and it suggests to us that perhaps one should focus on deep-rooted factors in comparative development. Namely, one should try to understand what is the origin of this differential timing of the transition between societies around the beginning of the 19th century. Now, unified growth theory that I advanced in the past few decades is an attempt to capture the process of development in its entirety. Namely, it's a theory that is designed to capture the existence of the world economy in the Malthusian epoch over most of human existence, literally 99.9% of human existence. And the theory is in fact show us precisely why is it the case that the Malthusian epoch lasted so long. At the same time, it is designed to show us what are the spontaneous forces that emerged during the Malthusian epoch that ultimately brought about the transition from stagnation to growth. These are the evolutionary processes that I mentioned, and this is the gradual acceleration in the rate of technological progress that ultimately increase the return to human capital and force people to start to invest in human capital at a certain point in human history. It will allow us to understand why, at a certain point, human capital, education, becomes so important in the growth process, and why many of us define the 20th century as the human capital century. It will allow us to understand why, at a certain point, the demographic transition takes place, and ultimately, what are the triggers of the transition of the world economy from stagnation to growth, and what is the source of the differential timing of different regions of the world from stagnation to growth. Now, the development of unified growth theory was a great mathematical challenge for the following reason. And I'm emphasizing it particularly in the context of an interdisciplinary audience. So naturally, if we think about the Malthusian epoch that lasted over 99.9% of human existence, to a large extent, this is a stable equilibrium. We see that over this time period, when technology is advancing, population is adjusting and bringing us back to the same equilibrium. So this is a stable equilibrium. Now, at a certain point, it appears that the world is able to take off from a stable equilibrium. Now, as a mathematician, you may know that in fact an escape from a stable equilibrium is virtually a contradiction in terms. Unless, perhaps, we have in the world several equilibria, each of them is stable, or some of them are stable, and we have an enormous shock that is shifting us from the basin of attraction of one equilibrium to another. But in fact, if we look at the evidence, particularly at the time of the Industrial Revolution, it appears that there is no structural break over this time period. It appears that in fact, TFP growth, total factor productivity, is growing exponentially but smoothly over this time period. And consequently, the mathematical challenge behind the creation of a phase transition, a transition from the Malthusian epoch into the modern growth regime, was the orchestration of this phase transition that is based on the evolution of latent state variables that are percolating behind the scene in the Malthusian epoch, evolutionary processes, and a gradual increase in the return to human capital that are ultimately causing the Malthusian equilibrium to vanish and the world to be gravitated towards the modern growth regime. So as I said, the evolution of a latent state variable ultimately permits the world to escape the Malthusian equilibrium, but not in a traditional way. The Malthusian equilibrium will simply vanish, and consequently the economy will gravitate towards the modern growth equilibrium. So if you think about the metaphor of the transition from liquid to gas, we can warm water gradually, and initially we do not see any change for a long period of time, but then when a critical point is being passed, in fact, we are moving from one phase, liquid, into another phase, gas. And here, we see a very similar process. For a long period of time, technology is accelerating with no effect whatsoever. The world remains in a Malthusian equilibrium, and then suddenly we pass a particular critical point in which people start to invest massively in human capital due to the fact that the technological environment is changing very rapidly, and educated individuals have a comparative advantage in adapting to this environment. So, the argument that is raised in the context of unified growth theory is that during the Malthusian epoch, population affected technology. More people, or better composition of human population, brought about greater technological change. At the same time, along the Malthusian dimensions, greater technology, more advanced technology supported more people. And therefore, if we started in planet Earth, say in Africa, 300,000 years ago with perhaps 30,000 people, these people sooner or later innovated. When they innovated, more people were supported. When more people were supported, more innovations took place, and this positive feedback loop accelerated the rate of technological progress up to a point in which human capital was essential in order to cope with this rapidly changing technological environment. When human capital started to be formed, naturally, this triggered the onset of the demographic transition, a decline in fertility rates, and consequently, it freed the growth process from the counterbalancing effect of population and allowed both technological progress and human capital formation to bring about sustained economic growth. So this is the viewpoint of unified growth theory. But most importantly, unified growth theory suggests that initial conditions are instrumental for the understanding of the evolution of each society in the course of human history. And as a result of it, unified growth theory suggests that initial conditions are critical for the understanding of the variations in the timing of the takeoff from stagnation to growth, and as a result of it, the divergence in income per capita as we saw it in the past 2 centuries. And consequently, much of what I will do here today will focus on these biogeographical factors that affected comparative economic development. So, I will talk about 2 fundamental theories that are linking, as I said, comparative development to its deep roots. The first one is the theory that is associated with Jared Diamond in his popular book, Guns, Germs and Stills. And Jared Diamond is making a powerful argument. And according to Jared Diamond, the timing of the transition of societies into the Neolithic Revolution, the transition from hunter-gatherer societies into agricultural society, is generating a technological head start, to those societies that transitioned a little earlier, that persist over time and ultimately contributes to comparative economic development. So this is one theory that I will articulate momentarily. And the second theory is a theory that I advanced in the past decade, which is the out-of-Africa hypothesis of comparative development, according to which migratory distance of Homo sapiens from East Africa, the cradle of mankind, affected the distribution of population diversity across the globe and consequently affected comparative development across the globe. Sorry. So let me start with the Diamond hypothesis. So according to Jared Diamond, the Neolithic Revolution which, as I said, is the transition of societies from hunter-gatherer tribes to agricultural communities, generated the emergence of non-food producing class, individuals that could be engaged in knowledge creation in the form of languages, in the form of science, and in the form of technology. And this knowledge creation generated a technological head start. Those societies that experienced the Neolithic Revolution earlier had more advanced technology that allowed them to form city-states, nations, empires, and ultimately to dominate the world. And according to Jared Diamond, much of the variations that we see across the globe today has to do with the timing of the Neolithic Revolution of different regions of the world. So as I said, if there are variations in the timing of the Neolithic Revolution, they will be behind the origin of the variation in economic prosperity across the globe. And the theory is, in fact, if you think about the variation in the onset of the Neolithic Revolution, it is quite apparent that the Neolithic Revolution is occurring first in the Fertile Crescent, in the city of Jericho, 10,500 years ago. It occurs independently in China, 9,500 years ago. It occurs independently in Mesoamerica, around 7,000 to 8,000 years ago. It emerges independently in South America and in some places in Africa. But importantly, the emergence of the Neolithic Revolution in particular places is associated with biodiversity in these places. Places that are more biodiverse, have larger number of domesticable species of plants and animals, and consequently they can move into agricultural communities earlier. But in addition, if you look at the Eurasia continent, the Eurasia continent is characterized by east-west orientation. And as a result of it, agricultural practices that are developing in the Fertile Crescent can diffuse eastward and westward into Europe. Agricultural practices that are advanced in China can again be diffused eastward and westward. But this is not necessarily the case in Africa or in the Americas that have the north-south orientation. So according to Jared Diamond, the prosperity of Eurasia today can be attributed to greater biodiversity in these regions that contributed to larger number of domesticable species of plants and animals and early domestication, and to the east-west orientation of these continents that brought about the diffusion of agricultural practices along similar latitudes. And consequently, this permitted an earlier Neolithic revolution, persistent technological head start, and ultimately domination in the post-colonial period. So this is one theory that I would like to consider empirically. It appears very powerful, and we will see momentarily what the data will have to say about the Diamond hypothesis. The second theory that I will focus on, and I will devote much of the rest of the time to it, is the out of Africa hypothesis of comparative development. And according to this hypothesis, the migration of anatomically modern human from Africa 60 to 90,000 years ago affected the distribution of human diversity across the globe for reasons that will become apparent, and consequently comparative economic development across the globe. So there are two main building blocks behind this theory. The first one is a well-established theory in the field of evolutionary biology that is known as the serial founder effect. And according to the serial founder effect, if you measure migratory distance from Africa, one would find lower degree of genetic diversity among indigenous population at greater migratory distance from Africa. The further you are from Africa, the less diverse you are. This is one building block, and I will explain it fully momentarily. And the second one, that is more rooted in the economic tradition, is the existence of a trade-off associated with diversity. Or if you wish, the existence of an optimal level of diversity for productivity in each stage of development. And this optimal level of diversity will balance between, on the one hand, the adverse effect of diversity on social cohesiveness, and on the other hand, the beneficial effects in the context of cross-fertilization of ideas and innovations. So as we know, humans are originated in East Africa, okay? And at a certain point, we see the migration of anatomically modern human from Africa, and a massive migration occurs 60 to 90,000 years ago. The migration occurs either along the southern route through the Horn of Africa, or through the northern route, through the Sinai Peninsula, the land of Israel, into the rest of the planet. People are populating Europe around 40,000 years ago. People are populating Asia around 80 to 90,000 years ago. Evidence suggests that humans arrived as early as 65,000 years ago to Australia. They arrived into the Bering Strait around 25,000 years ago, crossing into North America around 17,000 years ago, and into South America 14,000 years ago. Now, according to the serial founder effect, the exodus of anatomically modern human from Africa is basically causing departing population to carry with them only a subset of the genetic makeup that exists in the initial population. So if there is a certain level of diversity in the original population, departing population is taking with them only part of the diversity that existed initially. Why is it the case? If you think about sampling from a limited distribution, naturally the size of the population in Africa is small, and the departing population is small, and consequently, departing population is not going to represent all the variety and the diversity that exists in the initial population. And consequently, since migration is sequential, if people are migrating, say, from Africa to the Carmel Mountain caves, in which we found many evidence about the existence of both the Neanderthal men and Homo sapiens, then when people reside in the land of Israel, they don't depart immediately. They grow them, the population is increasing till the point in which the carrying capacity of the environment cannot support the population, and then a subgroup of this new colony will depart further. And since this migration is sequential, we will see further and further decline in the degree of population diversity as we move further and further from Africa. And consequently, as I said, one will find lower degree of genetic diversity as we move further from Africa into indigenous communities. So this is a simple illustration of the serial founder effect. If people are originated in Africa, and this is the degree of diversity that exists there, okay, so you can think about it as certain alleles of a particular gene. When people are moving, say, into the Fertile Crescent, some of the diversity is being lost. And then, if after a while they move thousands of years after into Europe, then again, additional amount of diversity will be lost. And the same will be true, and as they reach South America, naturally the degree of diversity will be the smallest possible one. Now, why is it so important? It is important because this suggests to us, if there is indeed an optimal level of diversity, it implies that there is an optimal distance of migration. Some societies were lucky to reside in a particular place on planet Earth that reflects certain degree of diversity that ultimately will be instrumental for the understanding of comparative development. Okay. Now, what we will use initially to measure population diversity is a measure that is proposed by evolutionary biologists, is known as expected heterozygosity, and this is a measure of genetic diversity. And what is it? It's simply the probability that two individuals sampled at random from a given population will differ in their genetic makeup. Okay, so it's a probability measure, and as we will see in the sample that we will have, this probability measure will be in the range of about 0.57 to 0.77. Now, what is the data that we will have initially in order to test this hypothesis? So initially we focus on the Human Genome Diversity Project that focuses on 53 population groups, okay, that resided in the same location for a prolonged period of time, that are isolated geographically, and that it appears that they were not subjected significantly to genetic admixture. And if you look at the sample that we have, you can see here that in Europe, for instance, we have the Basques, we have the Sardinians, we have the Tuscans. In Africa, we will have the Bantu and the Sans. In America, we will have the Pimas, the Mayas, the Pre-Columbians, the Suhuris, and the Caterina. In Asia, we will have in the sample descendants of the Han dynasties. And in Oceania, we will have the Melanesians and the Polynesians. So here, if humans are originated in East Africa, and this is something that most people will agree upon at this moment, and if you look at each of these red stars represent the ethnic group. And if we measure migratory distance from East Africa, say, to the Yucatan Peninsula, where this Mayan group is present, naturally we are not going to measure aerial distance. This is not a time period in which the Dreamliner could be used to fly from Addis Ababa to Cancun. This is a time period in which people walked. And therefore, we will allow them to walk, okay, according to different routes that we calculated based on different algorithms. So they will walk through the Sinai Peninsula, the land of Israel, the Bering Strait, the western coast of the America into this particular location. So we will measure migratory distance to each particular location on planet Earth, okay? And what will emerge is something very astonishing. If you look at migratory distance from Africa along the x-axis, measured in thousands of kilometers, so ranges from 0 to 25,000 kilometers in South America, the further you are from Africa, indeed, the lower is the level of genetic diversity. The most diverse populations in the world are in Africa, genetic diversity of about 0.77. So again, if I take two individuals at random from the Bantu ethnic group, the likelihood that they will differ in a certain spectrum of their genetic makeup is 0.77. If I will take two individuals at random from a Western Amazon population, the Suhuri, the likelihood that they will differ from one another is about 0.57. And this is what we see here. Very pronounced, negative, tight relationship between migratory distance from Africa and genetic diversity. And importantly, migratory distance from Africa alone explain 86% of the variations in genetic diversity. And this will be a powerful tool that will allow us to move forward and to project or predict diversity for any place on planet Earth. And why will we do it? Naturally, diversity may be endogenous to the growth process. Diversity may be an outcome of prosperity rather than the source of prosperity. And in order to avoid this, what we will do is we will ask ourselves, suppose that we see a place like Rome that is about 5,000 kilometers distance from Africa. Based on the regression line, I know that the predicted level of diversity in Rome is about 0.73, and this is the number that I will assign for the diversity in Rome. Okay, so first, I do not have the measure of the diversity in Rome, okay? So this allows me in some sense to construct a large enough data to conduct the analysis. But as I said, in addition, it allows me to overcome an important issue of endogeneity in identifying the causal effect of diversity on productivity. So again, just to make sure that we understand it, suppose that I focus on Rome in the year 1. And I see that Rome is very prosperous, as it was in the year 1, and Rome is very diverse. Can I conclude from this that diversity brought the prosperity? Not at all. It's possible that the prosperity attracted migrants to Rome, attracted slaves into Rome, and this brought about the diversity. So in order to avoid this entirely, I'm not going to take the actual diversity in Rome. I will say, based on this data that I have, and based on the serial founder effect, I can measure the migratory distance from Africa to Rome. Based on this measure, I can predict the level of diversity in Rome, and this is the one that I will take, and this will allow me to conduct an analysis that will identify the causal effect of diversity on economic development. Now we get into the trade-off associated with diversity. So as I said, it appears that one should expect to find an optimal level of diversity for different stages of development. And why is it so? Well, on the one hand, diversity will have an adverse effect on social cohesiveness. We know that more diverse societies tend to have more internal conflicts for different reasons. But on the other hand, we know that diversity is associated with cross-fertilization of ideas that can benefit society. And as a result of it, if we think first about the adverse effect of diversity more fully, diversity increases the incidence of mistrust, and I will show you the evidence for this. Diversity is associated with disagreement about the desirable public good, and I will show you the evidence for it. And consequently, diversity is associated with civil conflicts, and I will show you the evidence for it. And this implies that diversity is causing us to operate within the production possibility frontier, cause us to be inefficient given our technology. So these are the adverse effects of diversity. But as I said, there are beneficial effects as well. And the beneficial effects are based on the fact that diversity allows us to have complementarity in the production process, cross-fertilization of ideas, okay, that can stimulate innovations and technological progress. And in addition, diversity implies that we have a greater upper tail of the ability distribution that matters for innovations. And consequently, diversity will foster innovations and will push the production possibility frontier outward. Now, if we assume that there are positive and diminishing effects of diversity on innovations, and positive and diminishing effects of homogeneity on social cohesiveness, this would imply a hump-shaped relationship between diversity and development. And it implies that there is an optimal level of diversity. And then you can see where I'm heading to. It would imply that in some sense, some societies in the world were lucky to reside in a place where this place implied, in fact, certain level of diversity that may be optimal for development much later on in human history, literally tens of thousands of years later. So as I said, if you look at the support of the distribution of diversity, somewhere in the interval 0-1, and you look at productivity, there will be an optimal level of diversity. Societies that are overly homogeneous or overly diverse will not perform as well as societies that have the intermediate level of diversity. There is a sweet spot of diversity for development. But importantly, as we move into a more demanding technological environment, the benefits of diversity in terms of innovations will become larger, and as a result of it, in the course of development, as we move from technological progress that is low into technological progress that is high, the optimal level of diversity is predicted to shift rightward. This is the hypothesis. Now, if we want to test this hypothesis, there are several major hurdles. The first one, as I said before, is that observed diversity, particularly genetic diversity, is endogenous to the process of development. Why? As I said before, prosperity may attract migrants and may affect diversity. In addition, prosperity may attract conflicts, and through ethnic cleansing may reduce diversity or perhaps even enlarge it. In addition, observed diversity is available only at the level of ethnic groups. If we would like to understand the prosperity of nations, we will have to find a way to aggregate diversity from the ethnic group into the country level. And finally, we will have to take into account that there was a huge migration in the post-1500 period, and as a result of it, the diversity of the native population is not necessarily indicative of the diversity that will come later on. So for instance, if you focus on the US, Native Americans are less than half of 1% of the American population, so their degree of diversity will not represent the American population. So all these issues will have to be accounted for, and as a result of it, initially, I would like to focus on the pre-colonial era, say the year 1500. We're in the Malthusian epoch, post-1500 migration is not taking place yet, and as a result of it, I'm allowing myself to avoid the issue of migration in the post-1500 period. Now, as I said, in this time period, I will project or predict diversity to each country in the world based on migratory distance from Africa. This will allow me to avoid issues of endogeneity, and I will make these predictions based on their migratory distance from Africa. But naturally, we live in the contemporary world, and we would like to understand, if possible, how much of the variations in income per capita today can be attributed to this migratory route from Africa. And as a result of it, can we design a policy that will mitigate these initial conditions? And this will require the construction of an index of diversity, okay, that will take into account the proportional representation of different ethnic groups in each population. So if you focus on the US, 10% of the US population is originated from England, about 5% in France, about 5% in Scandinavia, certain fraction is coming from Africa. I will have to take into account the proportional representation of each ethnic group there, and each of these groups will be assigned diversity based on the migratory distance of this group from Africa. So if we have the British population in England, in the US, and they're 10% of the US population, I will ask myself, what is the migratory distance from Addis Ababa to London? And this will be my prediction for the degree of diversity in the English population that has 10% representation in the US. But in addition, I will have to take into account that mixing Danish people and Swedish people in the US is different than mixing Danish people and Chinese people, right? So I will have to take into account the pairwise genetic distances between the populations. Now, ultimately, and this is based on a recent release of data by evolutionary biologists, we will be able to conduct analysis across ethnic groups because, in fact, at the moment, we have a sample that is significantly larger than we had initially when we started the project. These are 230 ethnic groups for which we have observed diversity. In this case, we can use migratory distance from Africa as an instrumental variable to predict the effect of diversity on economic development. And in addition, this will allow us to project diversity, in fact, for nearly 1,300 ethnic groups that are included in the ethnographic atlas. So what I will do initially, I will ask myself how productivity in the year 1500, and as we know, productivity in the year 1500 is captured by population density because this is a Malthusian epoch. More prosperous societies are not richer, they have higher population density. So how productivity measured by population density is going to be affected by human genetic diversity that is predicted by migratory distance from Africa. So the moment that we are making the prediction, in fact, we are no longer referring directly to genetic diversity, we are simply predicting population diversity in these societies. And this population diversity can capture a lot of cultural aspects, a lot of geographical elements, etc. So we will ask ourselves how the migratory distance from Africa affects productivity. But we know that population density and productivity may be affected by the time elapsed since the Neolithic Revolution. This is the diamond hypothesis. And in addition, it should be affected by geographical attributes, absolute latitude, soil quality, percentage of arable land, etc. So this is what we will do initially. Now first, again, this is the measure of diversity that we have. The most diverse societies in the world are in East Africa, the least diverse one in South America, and this is the measure that will be captured here. So if you look at the table in front of you and focus first on the first column, we're focusing on productivity in the year 1500, in the Malthusian epoch, and how it is affected by predicted diversity and predicted diversity square. And you can see a pronounced hump-shape effect, okay, highly significant statistically. And if you focus on the sixth column, where we basically look at the different channels, genetic diversity is very important, predicted diversity. The time elapsed since the Neolithic Revolution, the Jared-Diamond hypothesis is very important, and geographical aspects are very important. And if we focus on this element, okay, the degree of diversity that is optimal for development, it's somewhere in between the two extremes. It's about 0.683. And it turns out that if you look at the relationship between population diversity and migratory distance from Africa, or genetic diversity or predicted diversity, the sweet spot of diversity is associated with Japan. Japan appears optimally diverse in this time period. Korea appears optimally diverse, and China appears optimally diverse. Now, typically, we don't think about China or Japan or Korea as optimally diverse, certainly not in today's world. But remember, this diversity is balancing between the importance of homogeneity for social cohesiveness and the importance of diversity for innovativeness. And this is a time period in which innovativeness are less important than today, and consequently the optimal level of diversity is associated with these places. And we will see how it changes in the course of economic development. Now, one concern that you may have is that perhaps everything is driven by distances that are entirely orthogonal to the issue of the out-of-Africa migration. So what you see in the first column here is we're looking at migratory distance from Africa, and you can see a pronounced hump-shape effect, as I suggested. But suppose that, in fact, I will not measure migratory distance, I will measure distances by aerial distances. If this will work, could be a blow to my theory, because maybe it has nothing to do with the migratory paths of our forefathers, it has to do with other distances. If you look at aerial distances as opposed to migratory distance, it is not only that the effect is insignificant statistically, the coefficient drops to virtually zero. So aerial distances are not explaining the patterns that we observe here. It's really about migratory distance from Africa. Another concern that you may have is that perhaps we're measuring distances from some point in the world, but I could have measured distances from a placebo origin, say London, and it will still work. This is not the case. So if you measure distances from London or from Tokyo or Mexico City, there is no effect. It's really about migratory distance from the cradle of mankind in East Africa. Now, another concern that you may have is that perhaps these distances are correlated with migratory distance from the technological frontier. Perhaps distance from the Fertile Crescent, which is basically the cradle of human civilization. So if you look, for instance, at the second column, okay, and you measure here distance from the technological frontier in the year 1000, the further you are from the technological frontier, the less productive you are. So this is fitting our intuition. Distance from the technological frontier has an adverse effect on productivity because we do not benefit from spillover from the frontier. Nevertheless, it doesn't really affect our result. Look at the optimal diversity. It's precisely the same number that I had before, 0.683. And the hump shape effect remains significant. And this is true for different time periods. Now, you may not like the measure of population density. If you focus instead on measures of urbanization, you have this sensational hump-shape relationship between diversity and economic development. So this is what we see in the historical context. But as I said, we are living in the contemporary world. We're not designed only, we're not we're not trying only to resolve fundamental mysteries in the growth process out of intellectual curiosity. If possible, we would like to design a policy that will expedite the transition of less developed societies from stagnation to growth and will reduce inequality in the world. And consequently, I would like to move into the contemporary world. And as I said, I will design a measure of population diversity that is going to be based on the proportional representation of each ethnic group in the population. 10% English people in America, 5% French, etc. Based on the predicted diversity in each of these populations and pairwise distances between them. So this will give me a new index of diversity, where again, the most diverse populations in the world will remain in Africa, okay? But now, for instance, North America is quite diverse, okay? Because naturally we have migration of Europeans and others into the America. The most homogeneous country in the world will be Bolivia, followed by Peru, Paraguay, and Ecuador, okay? And the most diverse population in the world are in East Africa. And now, if we look at the relationship between economic prosperity today and diversity, this is what we will find. So first look at column 4. This is a reminder about how we should think about population diversity in the year 1500 and diversity. So here, we see the genetic diversity and genetic diversity square as a pronounced hump-shape effect. We see that the diamond hypothesis is very, very powerful, and we see the geographical hypothesis is important. As we move and look at column 3 into the modern world, in fact, the effect of diversity becomes even more pronounced, hump-shape effect. But watch what happened to the diamond hypothesis. The diamond hypothesis was eliminated entirely. It's not only about statistical significance. The coefficient is 0. And the reason is that the diamond hypothesis is telling us when societies are moving into the Neolithic revolution, they have a technological head start. That's completely correct. But at the same time, at the moment that we move into the modern world and we move from the agricultural sector into the industrial sector, having a comparative advantage in agriculture is a curse, not a bless. And as a result of it, the diamond hypothesis is representing two conflicting effects: technological head start and lock-in effect in agriculture that are ultimately offsetting one another, and in the contemporary world, they explain precisely 0 amount of the variations in income per capita. So as I said, importantly, diversity is basically the most important element in what we see here. And importantly, if you look at the optimal level of diversity, it used to be 0.683 in the pre-colonial period, and now it's a bit higher due to the fact that higher diversity can generate benefits in the context of innovations. So if you look at the world at the moment, now the optimal level of diversity is associated with the level of diversity in the United States, no longer in East Asia, okay? It's higher than before, and more diverse societies are the ones that are more prosperous. So if you wish, this paper, to a large extent, is celebrating diversity. It suggests to us that, in fact, what happened in the course of human history is that societies that happen to be more diverse are gradually benefiting from this diversity in the context of innovations, and as a result of it, they're more prosperous. Now, it's important to note that the regression analysis is based on control for any ecological and geographical variables that were ever mentioned in the comparative development literature. It is associated with controls for democracy, social infrastructure, measure of institutions, major religion shares, legal origins, ethnic fractionalization, the disease environment, percentage of population, the risk of contracting malaria, etc. Regardless of the specification, all the results are highly significant, and you see that the optimal level of diversity is relatively stable. Now, in order to calibrate the effects, and the effects are mind-boggling, what we do is the following. As I said, the optimal level of diversity is associated with the diversity in the US. It's about 0.72. Now, let's focus on Bolivia. As I said, Bolivia is the most homogeneous country in the world. with a level of diversity of 0.63. So again, if I take two Bolivians at random, the likelihood that they will differ from one another is 0.63. If I take the Bolivian population, and if the Bolivian population would have had the level of diversity that exists in the United States, the optimal level of diversity, this change, holding education, institution, geography, the disease environment, etc., constant, will increase income per capita in Bolivia by a factor of 5.4-fold. Mind-boggling. Bolivia will move from having an income per capita of 8% of the United States to 40% of the United States on the account of diversity. Now, naturally, this is the largest effect that we will see in the sample. This is, again, a mind-boggling effect. If you take Ethiopia, the most diverse population in the world with a degree of diversity of 0.77, and we decrease the level of diversity in Ethiopia to the level that exists in the United States, the Ethiopian population will have an income per capita that is twice as large, from 2% of the US to about 4% of the US. Now, regardless of how we measure diversity, whether we measure it with income per capita or with light intensity as measured by satellites, we will see this pronounced effect. But as you know, I mean, for those of you that are engaged in economic research, and for those of you who can basically think about it and about the difficulties associated with this type of research, note that naturally some of these effects may be associated with country-fixed effects, something that we do not fully comprehend. And as a result of it, we move into an ethnic level analysis. So now we're focusing on ethnic groups only. Okay? And what we have is basically a new sample, as I said, about 230 ethnic groups for which we have observed diversity, which can be endogenous. And in addition, we can project diversity to all other ethnic groups that are existing in the ethnographic sample. Okay? First note, and this is very important, the same pattern of the out of Africa effect on genetic diversity exists in the enlarged sample. Now with the 230 observation, we see the same pronounced negative association between migratory distance from Africa and the degree of genetic diversity. Now, what we do initially is we basically take data on population diversity, population density in the world in the year 10,000 BC, 5,000 BC, in the year 1000 BC, and in the year 1500 AD. And in fact, we do it every 1,000-year period. This is the data that is available. And you can see in each time period this pronounced hump-shape effect of diversity on development. Okay? And it's completely, I mean, this is IV regressions, namely, we are instrumenting for diversity by migratory distance from Africa. If you look at the predicted sample, the same effects that will emerge. So again, it appears that regardless of the notion of a country-fixed effects, if we focus on ethnic groups and we avoid the issues of aggregation, the same pronounced hump-shape effect is present, namely there are certain trade-offs associated with diversity, and some societies were fortunate enough to have the optimal level of diversity for development in different stages. If we focus on these ethnic groups today, okay, so we look at the polygon of these ethnic groups, we measure light intensity in these polygons, again, you will see this pronounced hump-shape relationship, these are IV regressions, between predicted diversity and luminosity as measured by satellites. Now, so this is the reduced form relationship, and again, if you ask about the quantity, what we show is that 1/6 of the variations in income per capita today can be attributed to effects that occurred as early as 90,000 years ago. 1/6 of the variation. Now, just for comparison, if you look at the partial R square, namely the contribution of institutions, it is in the magnitude of 3 to 5%. If you look at the effect of say, cultural aspects, again, it's less than 3%. And this effect, migratory distance from Africa, is explaining much of the variations, okay, that we see in the data alone, in the sense that, again, migratory distance from Africa may contribute to institutions, may contribute to other elements, but migratory distance directly explain 1/6% of the variations. Now, what about the mechanism? First, note the diversity is basically associated with greater cultural fragmentation. So those societies that are originally more diverse will have more splitting into ethnic groups, and as a result of it, potentially more infighting. So this is in the context of the cost of diversity. Another thing that we see is that more diverse societies tend to be more heterogeneous in their preferences for redistribution. Right? And as a result of it, at the moment that we have disagreement, as we know, we tend to have conflicts, and conflicts are very costly for society. Third, diversity is associated with mistrust. Societies that are more diverse tend to be less trustful. And again, the likelihood of the emergence of conflict is larger. And you can see it even in individual level data. If you look at second-generation migrants today in the United States, okay, and you account basically for regional dummies in their ancestral environment, geographical dummies in their ancestral environment, and you compare people that are residing in the same county in the United States today, they're simply, one of them is coming, say, from Africa, where diversity is very large. Another one is coming from Europe, where diversity is moderate. And another person is coming from perhaps Bolivia, where diversity is relatively small. We can see that the larger is the diversity, the less trustful people are. Again, this is individual level data where we account for age, education, income, and point of residence at the moment. And these are not the migrants themselves, these are second-generation migrants. And this is true in Africa too. If you look at the Afrobarometer, and again, you look at people that are residing in cities in Africa, and you basically trace them into their ethnic homeland, those that are coming from ethnic homeland that are more diverse than otherwise will tend to be less trustful. So this effect, the adverse effect of diversity, and this is directly genetic diversity on trust, is very strong. And consequently, diversity is contributing to civil conflicts. So this is a paper that will be published in the coming months in Econometrica that is looking at the effect of diversity on civil conflicts. And what you can see here is that the more diverse a society is, the more conflicts will emerge in the time period 1960 to 2017. Interestingly enough, ethnic fractionalization, ethnic polarization is not important at all. It is all about interpersonal diversity. This is the first order effect. Similarly, if you look at diversity in civil conflict across all the sample of ethnic groups in the ethnographic atlas, about 1,300 groups, very pronounced effect. And finally, in the context of the benefits of diversity, we see that more diverse societies holding income and education constant tend to be more innovative. They have more scientific papers per capita. So we see the cost and the benefit of diversity directly too. So let me conclude. So what I showed you first are the foundations of unified growth theory. Why it is so important to have a unified framework. And in fact, your predecessor, Copernicus, was one of the main proponents of the idea of unified growth theory. In fact, in my textbook, before I knew that I will arrive to your university, so there will be no suspicion that this is an endogenous reaction. In fact, in my textbook, I'm citing Copernicus about his vision of unified growth theory in stimulating and inspiring my attempt to understand the world in a unified structure. So as I said, it's important to understand the world in a unified structure because much of the inequality that we see today, much of the transition from stagnation to growth was originated in the distant past. And the distant past is very important for comparative development. So unified growth theory is, to a large extent, is orthogonal to what I did in the second part. The second part is an additional research agenda, but naturally the two can be combined. Unified growth theory is simply emphasizing the importance of initial conditions, whatever they are, geographic, genetic, etc., in understanding comparative development. And the Out of Africa hypothesis is trying to articulate how important are these initial conditions. So what we showed here is that migratory distance of Homo sapiens from Africa affected the distribution of population diversity across the globe and ultimately comparative economic development. It accounts, as I said, for 1/6 of the variations in income per capita across the globe. You think about the competing hypothesis of Jared Diamond. It is entirely ingenious. The Jared Diamond hypothesis captures a lot of the variations in income per capita or in productivity in the year 1500. But in fact, it is entirely mute in explaining any of the variations today due to what I explained before, the conflicting effects that are associated with early Neolithic revolution. And as a result of it, the central player in understanding comparative development today in the context of the ultimate roots, both in terms of historical precedents, 70 to 90,000 years ago as opposed to 10,000 years ago of the Neolithic, but in terms of explanatory power is, in fact, diversity. Now, one important element. So typically there is a confusion about the argument about what is being advanced here. We do not argue that Eurasia is dominating the world because of any type of hierarchy of genes. This is not what we're saying. We're not looking at the mean level of the genes. In fact, if you look at migratory distance from Africa and different type of phenotypic expressions, the two are orthogonal. We're looking at the second moment, namely the collection of individuals within a society. Okay? We don't argue that in some places in the world there is a better genetic makeup. This is not what we say. We're simply saying in some places in the world there is simply a more desirable combination of people, each person with the genetic trait that they have. So it's not really about the genes, it's about collection. But as I said, beyond that, in fact, it's not about genes at all. The genetic diversity is allowing us to have a good measure of the degree of diversity in the society. It can be cultural, it can be other type of diversity, and this is simply a good proxy. Okay, an ancient proxy for the degree of diversity today that is not subjected to issues of endogeneity. Now, as you know, the writing of Malthus caused many to define the economics profession as the dismal science. And the reason is that naturally Malthus made predictions about the fact that food production is growing arithmetically, humans are growing exponentially, and consequently the human race is bound to suffer enormous amount of destruction and death. Now, this is not an attempt to contribute to the dismal science. In fact, it's not an attempt to argue that what we see in the world today is hardwired. Not at all. In fact, it is an attempt to develop a policy that can expedite the transition of less developed society from stagnation to growth, and in fact reduce inequality across the globe. And what is this policy? So when you think about policies that are typically heard about, say in the World Bank, and the World Bank will advance the ideas of democracy, and the World Bank will advance the idea of higher education, and the World Bank will advance the idea of population control. But again, the World Bank will have a universal policy for all societies in the world. Whether they will approach Kenya, whether they will approach Uganda, whether they will approach Bolivia, whether they will approach Poland, the same policy will be prescribed. Now, as we know today from other fields, particularly in cancer research, we move from universal treatment, say radiations, chemotherapy, into individual treatment that is based, for instance, on immunotherapy. Very similarly here, in fact, what unified growth theory suggests to us is that given the importance of initial conditions in comparative economic development, it's very important to design a policy that is geared to each individual country. And in the context of what I suggested here, it is about education policy. And what is suggested here, of course, more education is the better. But in addition, it implies that in overly diverse society like Kenya, where diversity is causing social incohesiveness, education policy should be geared towards social cohesiveness, respect for other ethnic groups, tolerance, because this will mitigate the cost of diversity and will allow the Kenyan population to benefit from diversity in the context of innovations. So again, it's not only about years of education, it's about the curriculum, and the curriculum will be country-specific. Now, if you take the other spectrum, the other end of the spectrum, say Bolivia, an overly homogeneous society, in an overly homogeneous society, naturally, you would like to be engaged, in the encouragement of cultural diversity. So if somehow the heritage of this society generated low diversity, partly because of the original genetic makeup of the population, naturally this can be mitigated by enhancing cultural diversity. And how can this be done? Naturally, we can think about critical thinking. We can think about thinking out of the box in general. We can think about cross-cultural exchange, or we can think about any education element that is encouraging people not to operate too cohesively. The problem of this society is cohesiveness. We want to operate against cohesiveness. So again, there is a way to mitigate this legacy of the past, but in order to advance this way, first we need to understand that this is really a very important issue, more so, as I said, than institutions in understanding development. Now, it's possible, for instance, as you know from the heritage of your country, that institutions are vital, right? Naturally, you had a tremendous transformation in the past 30 years due to changes in institutions. But this is not the world as a whole. In some places, natural institutions may be vital. In other places, this can be the dominating force. But even in the context of Poland, I think the issue of diversity and optimal diversity can be very important. Now, the final point that I would like to mention is the optimal level of cultural assimilation. So naturally, in an era of migration, countries are emphasizing the idea of a melting pot. Well, let's homogenize the population as much as possible so as to reduce the cost of diversity. So naturally, what this research suggests to us is that we have to be a little careful. I mean, over-cultural assimilation may not be beneficial. In some sense, you want to leave certain heterogeneity that can ultimately benefit you, but at the same time, you have to assure that the cost of diversity will not be overly large. Thank you very much.